Let us find an equation to represent the situation that we see here. What do we have? A train that travels 63 kilometers in its first phase. Now, do we know anything about the speed? No. Do we know how much time it took? Again, we have no idea about that. Now the train goes on to its second phase. It travels how much? It travels 72 kilometers. But this time there is a small change. What is it? The speed is increased. It travels at an average speed of 6 kilometers more than the original speed. So your original speed is S, your new speed is S plus 6. What about the time? The whole journey is covered in 3 hours. So if the first part of the journey is T, then the second part will be 3 minus T. Add both of them, you will see these two get cancelled and the whole journey is covered in how much? 3 hours. Now we need two different sets of equations. Why? Because we have different speed, different distance. So let us write down two equations. What is the first equation? Your speed is your distance by your time. This is the first set of equations. The second set, the speed changes, the distance changes, and we don't know anything about the time here. Now we have two equations here. Now look at these two equations. Are we going to get a linear equation in two variables or a quadratic equation in one variable? I often see students getting confused between these two. Now when you see the word linear, what does that mean? All the variables that you have here, their exponent must be 1. It has to be 1. It cannot be greater than 1. It cannot be 2, 3, or it cannot be minus 1 or minus 2. You cannot have that. All of their degrees has to be 1. But then, and of course you should have two variables. You have S and T here. You should have two variables and all of their exponents should be 1. But when we talk about quadratic equations, your unknown is just 1. It is just one variable, one unknown, but its degree should be 2, which means what? It cannot be 3 or 4 or anything. It has to start from 2. But all of this is not necessary. You can have a quadratic equation even without the x term or even without the constant term, but you need to have this one. The exponent raised to 2 has to be there. Now comes the question. You have two variables here, but is it a linear equation? No, it is not. Why is that? Here it is s raised to 1, but what about this? Here it is coming in the numerator, which means it is t raised to minus 1. Here also it is the same. Here you have s is raised to 1, but this, the t, again you have it in the denominator. In both the cases you will see that the t comes in the denominator, which means it is t raised to minus 1. So what you get will not be a linear equation in two variables. You have to get rid of one variable somehow, and then you will get a quadratic equation in just one variable. Out of the two, get rid of one, make it just in terms of that t. Let us see how to do that. Now here we have two unknowns and two equations. Let us get rid of one unknown, one variable. Now t comes in the denominator, so it is going to be a lot of headache if you try to get rid of it. S will be easier to remove. What do you have to do? Just do 1 minus 2, that's all. Both the s will get cancelled. If you subtract this from this, both the s will get cancelled, and here you will get just a 6. And now subtract the other two, you will see that 72 and 63, make it smaller as much as possible. Make your equations smaller. Take out the 9, there you have two fractions, find the LCM, and then you will get such an equation. So this is the quadratic equation that we arrive at. We need two numbers such that their sum is 39 and their product is 2 into minus 63, which is minus 126. Now forget the minus. Look at all the possible combinations. I have written down a few here. You don't have to go that far. Just whatever number you have, try subtracting them. You have a minus here. Remember, if you have a plus here, A and B, if you have plus, then you have to add the two numbers. Always remember, when your A and B you have a plus, you have to remember it means two things. It means both the numbers that you are looking for have the same sign. They are both positive or they are both negative, and what you have to do is add them. Then you will get the corresponding set of numbers. But then when you have a minus here, that means what? One of them is positive, the other one is negative, and to find them you have to subtract. So keep on subtracting these numbers and see when you get 39. Subtract each set of numbers. When you come here, you will see that 42 minus 3. You can stop here itself. 42 minus 3 is what will give you 39. So the numbers here that you are looking for is 3 and 42. But remember, you have a minus here, which means what? One of them is positive, one of them is negative. Look at the number here, look at its sign. Its sign will be the sign of the greater number here. So if this is plus 39, then what you have is plus 42 minus 3. On the other hand, if you have a minus here, that means what? The signs are interchanged. We have done a detailed video on this. Please check it out. Now, solving this equation, you have two such factors and you have two possible values for t. But then what can t not be? It cannot be negative. Your time, your weight, your age, none of them can be negative. They have to be positive. But then be careful. It is 3/2 hours. We are measuring it in hours. Do you remember the question? All our units were in kilometer per hour. So this is 3/2 hours, which means 1.5 hours, which means what? 1.5 hours. But that is not our question. Our question was not the original time taken. It was the original speed. Now we had to find the original speed. We found that the original time taken was 1.5 hours. The distance traveled was 63. So when you substitute it, what do you get? The original speed is what? 42 kilometers per hour. That's all for today. Take care. Assalamu alaikum.